really started getting a little bit weird when you got to around 9 and 10, when you had to worry about the denominator. Real quick, I know I think we talked about this yesterday. When it had 50s in there, or 350s, are those the same angle measure?
Yeah.
So as long as it's the same value, properties hold true.
Okay.
So cosine squared of 50 plus sine squared of 50 is still 1.
Yeah.
It doesn't matter. That doesn't have any difference at all. Yes, sir? Then it won't work. The properties aren't going to work. Then you have to do a whole bunch of other stuff, and you'll worry about that next year and pick up. So let's take a look at 9. Let's just jump right into 9 and kind of build our way out of it.
Okay.
So at 9, hopefully you guys started to notice this, that if you did one of them, the next one was usually very similar to it. So what I like to do when we have fractions, do you hear all that too? It sounds like someone's swearing at each other. Okay. Merry Christmas. When I see fractions, a lot of times what I'm going to do is kind of, excuse me, first I look at it and say, hey, can I simplify something out of it, or should I try to get a common denominator? In this case, I notice that I have sines and cosecants, cosines and secants. Aren't they inverses of one another?
Yes.
So what I'm going to do is just rewrite each part. So you have sine times 1 over cosecant plus cosine times 1 over secant. I'm just splitting it apart. A lot of you guys can probably do these steps without showing it. I'm just showing why this is going to work. 1 over cosecant is sine. So you have sine squared plus cosine squared, which is 1.
Oh, I get
Well, remember, you can go that step further. What does it equal? It equals 1. Okay?
Is that one of the
It would be, yes. It's probably, bless you, it's one of the most important ones. As you get into the other ones, you get, on 10, it's basically the same idea. On 11 and 12 are so stinking similar, it's ridiculous.
Yeah, I was so worried that I was doing it wrong.
No, because hopefully you noticed that secant times cosine, isn't that 1?
Yeah.
So these two are really the same problem. So what happens here is that when you have a fraction and then you have a -1 tagged in, that's usually when you're going to want to try to get a common denominator, or look at it to see if you can get an identity. When I'm looking at this, since there's a -1, if I try to see, well, if I get a common denominator, does it really get me anywhere? No. But secant and cosine, aren't they inverses of one another? So if I bring cosine up to the numerator, what does it become? So it becomes secant squared -1, which is? And it's the same thing for the next one. The only thing you had to do in that second problem before you could write it out was the fact that secant times cosine is 1. Okay. And that's how that works. Yes, ma'am. Sure. And 6, this is the one we FOIL out, and you get a difference of squares. If you FOIL that out, you get secant squared plus secant minus secant, so I don't write it, -1, which is tangent squared. Yes, ma'am?
What is that symbol?
Phi.
What is that?
It's just another Greek letter.
Like, it still means angle?
Yes, ma'am?
Oh, sorry. Can you do 13, 14?
Okay. I think that's phi, right?
I don't speak of the
Is it?
I know what you're talking about. I think that's
epsilon.
Because,
I think that is B.
or is that phi? I don't know. I fell asleep in mythology class in college. I smell the blood of an English bug.
sound like a rebel.
It sound like who?
Like a rebel. Like in class, you're like.
And hair back then, just like I do again today.
Makes sense.
I gotta get cut. It's just out of control.
I don't know the last time I
When you say you're gonna get it cut, are you gonna shave your head again?
I want to.
Shut up.
I saw a picture.
Anyway.
But you look so much less scary with hair.
You look like dad next
Yeah. But when your head's shaved, it's scary.
I'm scary looking, yes.
You should keep growing it. You look
People-
like the dad next door.
I often got confused with being a cop with my shaved head. So, yes, ma'am.
I could see.
So the top, is that secant square?
Yes.
Wait, what number?
Now, there's a couple of things you can do here. There's a couple of things you can do here. If you want to go right out to the Pythagorean identity, then you have 1 plus tangent squared, you get secant squared. And you get secant squared over tangent squared. And then you can rewrite everything in terms of sines and cosines. That's fine. Another way you can do it, I'll show you both ways. You go secant squared over tangent squared. Secant squared is the inverse of what? Cosine. So this is the same as saying 1 over cosine squared. This is times 1 over tangent squared. Do you agree? All I did is just pull that denominator up.
Yeah.
1 over tangent squared is what?
Cotangent.
And which cotangent is what over what?
Cosine.
So is it okay if I just erase this and write cosine squared over sine squared?
Yeah.
Is that okay?
That's fine.
So this is one over something.
So you wind up with 1 over sine squared, which is cosecant squared. That's one way to do it. Another way is sometimes what happens if you don't recognize the Pythagorean identity and you have 2 parts in the numerator with a singular denominator, rewrite it as 2 separate fractions. Sometimes it helps. Okay? What I mean by that is I'm going to split apart my denominator and I get 1 over tangent squared plus tangent squared over tangent squared. Are we okay with that? 1 over tangent squared is what?
Cosine.
Cosine over sine.
Or cotangent squared, right?
Ah, you keep saying
I'm doing that first.
when you want.
It's, well, that's okay. And then, because what's cotangent squared plus 1?
Cosecant squared. Oh, that's easier.
Either way, there's more than one way to do most of these problems. Okay? You just got to remember your identities. Okay? Yes, sir.
Just when you not necessarily apply this problem, but like when you do like say sine divided by cosine, is that the same thing as sine times 1 over cosine, which is secant?
Because isn't 4 divided by 2 the same thing as 4 times 1/2?
Of course it is.
It's the same thing. They mirror the same properties of regular numbers. 14 is very similar to that.
Okay.
Okay? Let's go to the second part. Now, what's nice with the verifies, at least you know what the answer is supposed to look like in the end. It's just, do you know enough to show that it works? Okay? So if I'm looking at the first one, sine squared times the quantity 1 plus cotangent squared, one of 2 things you can do. You can go ahead and distribute right away, or since you have a 1 plus something else squared, check and see if it's an identity.
Sine squared.
1 plus cotangent squared is? So if I'm just going to rewrite sine squared times cosecant squared, aren't those inverses of one another?
Yeah.
What happens whenever you multiply inverses together?
They draw some.
It equals 1. You're done.
A 31.
It's fine.
Second one, a little bit more work.
This one was confusing.
So we have sine squared, then we have a cosecant squared plus a secant squared. And I want to prove that it equals secant squared. Now, what I'm going to do is I'm going to rewrite my stuff within the parentheses as fractions. I'm going to rewrite them in terms of sines and cosines because they're both inverses. You guys okay with that?
Yeah, that's fine.
So I get sine times the quantity, or sine squared, excuse me, over 1 over sine squared plus 1 over secant squared. Oh, sorry, cosine squared. So now when I distribute, I get sine squared over sine squared plus sine squared over cosine squared.
Oh, and then, you distribute the signs.
And you get what?
1 squared plus
1 plus tangent squared, which happens to be an identity, and that equals? There you go.
That wasn't as hard as Oh,
33 and 34 are also very eerily similar. You're actually going to do the same step in both of them. What a strange coincidence.
I missed the deal going.
It's trust me, no. So we have cosine squared minus sine squared. Well, that isn't an identity. That doesn't help me with anything. But my answer wants to be written in just sines. So can I replace cosine squared with something?
Yeah.
Cosine squared is equal to what?
Signs.
So I get 1 minus sine squared which is 1 minus 2 sine squared. Done.
What? Okay, so you sort of did like the diamond thing backwards.
Right.
Okay.
You're just using substitution.
That means that.
So now if you look at the other one, cosine squared minus sine squared, you want to have 2 cosines.
So you have to do the two signs.
Correct.
Squared.
So you-
Equals 1 minus.
So you have cosine squared minus the quantity 1 minus cosine squared. So you have to distribute out the negative, and that's how you make this work. You have cosine squared minus 1 plus cosine squared, and now you're at 2 cosine squared.
I'm sure you need that same cosine.
Wait. Can you do cosecant squared minus cotangent squared?
It's one.
I mean, yeah, I got one, but
I
Yeah,
don't
it's
know
one.
if I did it the right.
I think you did, don't worry.
I don't think I did the
Because if you move this over, doesn't cosecant squared minus cotangent squared equal 1?
Yeah, but don't you have to do like math?
You did. You subtracted.
I did like,
You did it right.
Those problems confuse me more than
Yeah,
they probably should.
it's fine.
Okay. Try the more complex ones.
Yeah, sure.
Moving on. Or is there more tonight going to be on the sheet?
Now I got new stuff.
Okay.
Wait, are we passing this up? Or?
No.
Okay.
I was just adding on.
Add it on. Yeah, add on wherever you want to put this in your notes. I'm just going to kind of show you a couple more tricks and things and how to set them up.
So are we not like really like covering anything else besides 14.3 for the next like 3 days?
Yeah, because then we're going to go back into, there's a couple of equations that we have to solve that you have to use identities to simplify. So there's a couple of those in 14.4. Because we're testing out of this stuff on Friday.
Okay.
When I say we're testing out of this stuff, we're going to do all the non-calculator stuff that we've been doing for the past couple of weeks. Friday. Evaluate, simplify these things, verify, simplify, solve equations. It's a full-on non-calculator test. And then next week, that'll give us time to do the graphing. And hopefully get that done before break, which we should. There's no reason for that. Yes, ma'am?
For this Friday, are we gonna have to have this stuff memorized?
Oh, yeah.
Or no pickle?
No, you don't get a sheet. You get nothing. You like it.
We have to know all this?
Yeah. You know all of it. The only ones you don't know are these identities. That's it. The ones you don't know. But sine squared, cosine squared, you know that. That's easy. You just got to memorize 2 of them. Yes, ma'am?
Okay. So are you gonna send anything over this so we can make like this just like it or?
Oh, the
I
table.
wouldn't do it anyway. I wouldn't do it.
He gave us a take home quiz.
It was awful.
I know. I've seen that take-home quiz. I've tried to take that take-home
Isn't it
quiz.
really hard?
It was pointless because he said we could use people's help.
We all did it.
We had, I had a take home midterm final, or midterm over in one of my calculus classes in college, where they gave us all these proofs that we had to do. Well, there's this thing called Google. I don't know if you've heard of it. It helped me get a B. That's all I could get was a B, because it was hard. So, yes ma'am. There's no point in take homes.
I remember when he like gave us our take home quiz, like since the like 8th graders or whatever that were in that class, we like took a bus there and then like here and then took a bus back. We did
We
like
just gave each other all the answers and pressed over.
we always did the take home quiz on the bus.
Did the wheels on the bus go round and round?
Yeah.
Wait, you guys have to take a bus?
Anyway, so here's what we got. In this one, the first one here, your numerator has just multiplication. Your denominator has the starts of what looks like it could be an identity. So what does the denominator simplify out to be?
Cosine squared.
Good. So what happens here is you start to piecemeal some things together.
We can put this on our notes.
So that's fine. And what happens?
You cancel out the cosine and one of the cosine.
So what do you get?
Tangent.
There you go. Okay.
Easy.
Sweat.
All right. Same basic idea in the other one. Notice how they're kind of the same problems. They're just different function of one another. What do you do to the numerator? So now you have sine squared over your sine cosine. And once again, what do you wind up getting? A tangent. Not. It's tangent. You still have sine over cosine. Okay. They start to mirror each other quite often. And that's why I said yesterday, if you get really frustrated with one problem, go to the next one, because it's probably the same thing as the one you just tried to do. It happens a lot of these things. Did you get more than half of them last night?
Yeah.
Then you did fine. Seriously.
Wait, so if I get like 50% on the test, it's fine?
That's not.
Okay.
But remember, like I said, for the first round of some things that I believe is one of the more complex thought things that we do, you're fine.
I think it's fun.
Good.
It's like a puzzle.
And I'm not gonna lie, I think with this class versus from what I've had, not just last year, but in other years, there has been a lot less whining in this section, which is weird. Usually people are just want to throw stuff at me like this.
Can I throw up the
Like, you got me so worked up about the section, and I thought I was gonna like go home like crying each night, but it's actually so much easier. And the stuff you say is gonna be easy, like so.
March 17. It's gonna be on purpose now.
Me? No, I don't do stuff like that. I think we talked a little bit about something like this yesterday. Is noticing what you start with and what you have to end with. When you have verify problems, you can sit there, it's probably less obstructive.
But then I can turn awkwardly.
What happens a lot of times when you see something that starts with addition, ends up in multiplication, that usually meant that you had to get some sort of a common denominator to create a fraction. Okay? Now, when we're dealing with cotangents and tangents, and you wind up with cosecants and secants, somewhere along the line there had to have been what's? Cosines and sines. So when I see something like this, I'm only going to work with left side. I want the left side to look like the right. I'm going to rewrite the left side in terms of sines and cosines. So cotangents, what over what? We have cosine over sine.
Wait.
We okay on that?
Yeah.
All right. Now, if I want to get a common denominator with this case, what would I have? Or let me start with this. If I want to do a common denominator of 1/3 and 3/4. So my common denominator would wind up being 12. Fraction on the left needs a what? So it'll be a 4 times 1. Fraction on the right needs to be multiplied by? So you wind up with 1/3 plus 3/4, so you get 4 plus 9. Okay?
Okay.
What changes with sines and cosines? Nothing.
Wait, didn't we already do this?
We started a little bit of it. I'm just trying to.
Like something before where we had to multiply together and we
Uh-huh.
took down.
Yep, we did that with how?
Something like that.
That one thing
I think it was
It
polynomial.
was polynomial.
So fraction on the left, what does it need?
A cosine.
What's cosine times cosine?
Cosine squared.
What's the fraction on the right need?
Sine squared. Sine.
What do you get?
Oh, sine over. Oh.
Hold on, what?
Cosine squared plus sine squared equals 1.
And your denominator is sine squared times sine times cosine. So what's 1 over sine times cosine?
Cosine over.
Cosecant,
Oh,
secant.
that's what I meant.
You're done.
Wait, how does that?
Because you pull it apart,
So it'd be 1 over sine times 1 over cosine.
which is secant equals.
So this equals secant times, excuse me, cosecant. Secant. That's a little bit of the trick. When you see something that starts with addition, ends in multiplication, it means you're usually going to be working with the common denominator to flip things around. Okay.
The shark from time.
All right. You say you. So I have sine over 1 plus cosine. So in this one, I really can't split anything apart because I got the addition in the denominator. 1 plus cosine is not one of my Pythagorean identities. So if I wanted to make it a Pythagorean identity, what would I multiply by?
No, you'd have to do.
1 minus cosine. I have to multiply by the conjugate here.
Wow.
So your little trick here, when you see a 1 plus a trig function in your denominator or 1 minus a trig function in your denominator, and that's all it's there, it's usually setting you up to do a conjugate.
So multiply it by 1 minus cosine?
Yep. Because the conjugate of 1 plus cosine is 1 minus.
Cosine squared.
So when you FOIL all that out, you get 1 minus cosine squared. Do you agree? And what's 1 minus cosine squared?
Negative sine squared. It's just sine squared.
Just sine squared. Bless you.
Sine over sine.
Oh, it's 1
Okay.
minus cosine? Yeah.
When you FOIL out, you get 1 plus
Yeah.
cosine minus cosine squared.
I did it weird.
Okay. Your numerator, if I just rewrite my numerator, it's just going to be sine times the quantity 1 minus cosine. I could distribute, but does that really get me anywhere? No. It makes it dirty. So it goes over sine times 1 minus cosine all over sine squared. What happens?
You get 1 minus cosine over sine.
Yep. Sine drops and you get 1 minus cosine all over sine.
And 1 minus cosine is also sine squared. But
No.
Stop.
It's not squared. Now, take a look at what you have. You have 2 terms in your numerator and a single term in the denominator. Split it.
Oh.
Oh, that's what you do. And what's 1 over sine?
Cosine.
And what's cosine over sine?
Tangent.
And you're done.
So irritating.
Yes, yes it is. Yes it is. These things.
Just whenever there's addition and subtraction, it like throws me off so bad.
All right. Well, what if I throw the kind of the nasty one?
Well, the question is, why would you do that?
Because that's how I roll.
Because we're not whining enough.
Yeah, because you're not winding it up. You're right. Secant minus tangent all over 1 minus sine equals secant.
Okay, well.
Ooh, I can do this. You just,
What it is.
I got this. I hope.
The verify ones are so much harder than the.
I think they're easier because
At least you know, you at least know what it's supposed to look like in the end. It kind of helps you get an idea.
But you gotta like look at it for 5 minutes before you know how to start.
Well, knowing the problems that we just did, what do you think I want to do to start with this?
Ooh, you
The
want to
conjugate.
different.
I can't separate because I have two terms in the denominator. If it was a single, I would.
Multiply by 1.
We okay with that?
Yes, for sure.
yes.
So my denominator becomes 1 minus sine squared, which is what? Cosine squared. So I'm just going to leave that guy alone. My numerator, on the other hand, is a bit messy. It's a smidge, not by much. So I'm going to work with the, I have secant minus tangent times 1 plus sine. One of two ways I can go about doing this. Secant and tangent, can I rewrite those in terms of sines and cosines?
Yes.
All right, I want to do that, or I can do the foiling out at this point. Probably don't want to foil at this point. So here's what happens. If I take this value, my secant minus tangent, do you guys agree that it is 1 over cosine minus sine over cosine?
Yes.
So 1 minus.
Oh, I didn't do
Oh.
Are you okay with that?
Yeah. For
Okay.
sure.
So what I'm going to do here is, this is going to become 1 minus sine over cosine
Gross.
times, nothing squared, times 1 plus sine over 1. That's this part here.
Why is it 1 minus sine?
Because there's a minus sign right there.
Secant 1 over cosine, tangent sine over cosine, they have the common denominator, so it's 1 minus sine. Okay? I just did it in a separate chunk there. Sometimes you have to piecemeal some of these together to make you really think about what's going on.
Because I was just writing it and I missed that little chunk.
Okay? In last time I checked, when you're multiplying fractions, you just multiply numerator, multiply denominator, right?
Yes, sir.
So what's 1 minus sine times quantity 1 plus sine?
1 minus sine squared.
Oh, that's dirty.
It is, isn't it? Because now you get 1 minus sine squared over cosine, all over cosine squared.
Also, 1 minus sine squared is also cosine squared. So those just.
So you guys are going to get kind of perturbed at this point.
It's cosine squared over cosine over
It's
cosine
cosine
squared.
squared over cosine squared.
Oh gosh.
How do you cancel that
So
out?
would that be?
Carefully.
cosine over
Let me ask you this.
Wait, I get this. No, I get it. No,
Do you?
from the top fraction first, we do the like squared and then like the denominator. So then it turns cosine over cosine squared, right?
Or, better yet, do it the right way.
That was right.
Not quite, you're missing out on value here. This is my numerator of my
1
nasty.
over cosine.
This is my numerator of my nasty fraction.
Yeah.
This is my denominator of my nasty fraction.
Yeah.
So, top divided by bottom,
You switcheroo.
you fool, multiply by the reciprocal.
Oh, no, those can tell us it's 1 over cosine. I did do it wrong.
Oh, you were going backwards. You were saying it's going to be cosine.
No, I said 1 over cosine.
No, you didn't.
If you did, I misheard you. If you did, I misheard you. I apologize.
Okay, I'm not gonna be. This is what I was gonna do. See, I was just gonna go like this.
Yeah.
And then you have cosine over cosine squared. And then you have this. And then you have 1 over
Yeah, that's all I did.
It's dumb luck because that doesn't work. Oh, I see what you did. Yes, because it dropped down. Okay, yes. Okay. I was thinking you were doing something differently. You're right. Yours did work. It worked. You played Burger Time with it. Then when we get burger time, I'll show you
But
burger.
now I really want to.
What?
What you did is you did the burger time game. This will make sense if I show you the video game. You went, you knocked this one down, knocked it down. That's kind of what they did in the game burger time.
If you put peaches in it, cottage cheese with peaches. I put
Cottage
chicken nuggets.
cheese is just the most disgusting
Thank
thing in the
you.
world.
I love cottage
The
cheese.
smell of it makes me want to vomit.
No,
I put it in burger.
What? That's even worse!
Okay, I
No. You don't understand.
Pineapple.
You are ruining your nuggets!
You know.
Okay, cottage cheese and chicken nuggets is the best thing.
Disgusting. I can't even believe that. I was going to the other spreadsheet was
Cottage cheese
over.
and pineapple in it?
No, pineapples are gross.
What?
It's so good.
You're the most ridiculous person I've ever met.
I love cottage cheese.
When I was younger, I tried lemonade with graham cracker. It was so gross. My brother put salsa on a tortilla with blueberry yogurt.
All right, let's do another one.
Love it. Love the cream cake. So next time I have cottage cheese and chicken nuggets, I'll send you a snack.
That sounds.
I honestly, like, everyone's like disgusting.
Yeah, I got
They make them fight and they like
34.
it. And it's
Excuse me.
delicious.
My brother's like some kind of
That's
prodigy.
okay. I studied mechanical engineering at Eurobot.
What's wrong with you?
I don't know. I've been trying to figure it out for like 15 years now.
I'm just messing with you. Do this one, then I'll give you some different ones. Verify it.
Pop to the top.
You can verify.
How do you do that?
Got you.
Good one. That's my name.
You see, like when we go through it as a class, like I totally understand it, and I can see what you're doing, and then like you're like, do this, and
I always want to be close.
It makes sense until I do it alone. Like while we're in class, like right now, this like makes sense, and it's
she shot you down.
like.
I'm
Anyway,
sorry.
Then I go home and I try and do it and I can't get it. That's one
Cool story.
I'm not on speaking
You want to speak in terms of food?
my mother.
Why?
She wore a phone gave her.
I love your mom. It's so funny.
What are you gonna do first?
You're gonna multiply it by time one more
That's
time.
on the road. That's
one
more.
Then you're gonna be really no. Hey, I forgot my phone at home today, and I have a meeting, so I'm not gonna get it.
So now you wind up with what?
One minus sine squared on the bottom and cosine times 1 plus cosine on the top. It's just cosine.
Wait, is that really close?
Cosine.
Yes, Allie, it truly
Yeah,
is.
1 minus sine squared is cosine squared.
Oh, I didn't know we could.
So then you end up with.
You just.
Okay.
What is sine over cosine? I don't really know what to do with this.
You just gotta pull it apart. 1 over cosine
Oh, Clara, you are so smart.
plus sine over cosine, which in other words is 1 over secant plus burn. Straight fire.
Oh, where'd you go?
I don't understand how this was like so hard to Austin.
It's the same thing. Okay, question.
That's not what they wanted, is it?
No, wait. But you.
What?
But then you can divide by. Wait. How did you get one? How did you get secant plus tangent out of 1 over cosine? Take on maybe one.
Because it's just, there's no
Very
1
worst.
on top.
1 over cosine is secant.
It's not 1 over secant. And sine
It's not
over
necessarily
cosine.
1, is it?
Oh.
So what went wrong?
I don't know.
Me either.
Is it like?
No, if there's a solution, there's a solution. What do we do?
Divide it all by 1.
Wait, that doesn't work. Do you like do the inverse stuff and then
Well, let's see what we did.
We're gonna get to the bottom of this.
Let's see what we did. So we have we multiplied by our conjugate, which is fine. Okay. And we wound up with 1 minus sine squared. Okay. 1 minus sine squared gave us a cosine squared. Okay. Now let's see. Then we have cosine. So we wind up with secant plus tangent. We got to get it secant plus tangent, which would be 1 over secant. They split it over again.
See, look, he doesn't know what he's doing.
Actually, you know what I'm looking at? Where did we go wrong?
I don't think so.
I vote that we just don't know
Please, no, it's not.
Because, I mean, the way we went through it was completely right, like.
Yeah. Well,
So I don't understand where this like 1 in the numerator comes from. But I mean, secant is cosine 1 over cosine. So if you have cosine in the top, no, if you have secant in the top, oh, I got it. How? I got it. Okay, can you tell it to us?
Give me a second.
If you got it, like share it.
Give me a second. Friends.
I wonder if they multiply by cosine to start with.
Why would it? Why? What? No.
Why? That's not what happened. No, I like the way that we did it.
I was so like happy.
It's like the people that make this problem, they take that and then they try to make it as different as possible. Why would they do that? Do we decide? Sine over cosine tangent. Okay.
But then you just use dog.
Wait, how'd you do one plus sine?
Why are you standing up?
Is this
Is that right? Or
It's the same
yeah, and then
place
you
we
would
were
pop
just
it out.
at.
Yes, oh, you get 1 plus sine.
You just wind up these going to drop out. I have the same answer. I don't know what I did wrong.
he's so upset.
I've done this before, and I don't know where.
Wait, is it 1 over cosine?
It's 1 over secant minus tangent.
Secant? Oh, I got
What?
You're breaking that. I got something like that.
He's so frustrated.
What number was this?
55.
I'm starting
Guys, this
like
over
looks at
the
paper.
This upsets me. That's like worrisome. Like, what? How are we supposed to
And
figure
I have
out?
just marked off that it's not right. Maybe. Don't know. Crap, I had to pick one.
Can you
I
like Google
know.
this worksheet?
Now you've done it. We've only got 8 minutes left to figure it out.
Page
I'll figure it out.
Oh, this is Montana.
640. Exercise B number 55.
All right, let's see this one instead. I'll get you the answer.
You promise?
I promise.
Like put it on the website or something?
Those shoes look like.
Do 51.
Does this one work?
Yeah, and I lost like trust. Like I can't trust yourself.
The second that your math teacher like
What are you doing, Chase?
is struggling with the problem as much as you are,
I lost trust in Miss
I'm not
Todd.
like.
Oh.
Second I saw her.
no, like Miss South would like
She was always wrong.
put notes up on
She
the
was
board and
always
you're like,
wrong. Did you just skip that problem? He's going back.
he's gonna figure it out and then let us know. Hopefully.
First thing tomorrow when we walk into the classroom.
Put it on the website. I can't wait until tomorrow.
Yeah, post it on the website.
Actually, you know what?
All night figuring out the problem.
Do 50 instead.
Just wrote it down.
Why can't I do 51? You know?
No, this one's a little bit cleaner. It's for.
Sweet.
At this point,
Okay.
I'm still working on 50.
I still look good.
Yeah.
All right. So if I'm looking at the left side there, what I want to do is I need to make it look like 2 secant squareds. So I'm going to get my common denominator. What's going to be the common denominator between cosecant minus 1, cosecant plus 1?
Cosecant squared minus 1.
Right. So the common denominator, I'm just going to write it out long form right now, will be cosecant minus 1, cosecant plus 1. And we know that I'll simplify in a minute. Fraction on the left, we need a cosecant and a cosecant plus 1, cosecant, cosecant minus 1. You okay with that?
Yeah.
Sure.
Yes.
So, numerator, excuse me. Numerator-wise now, move this over. We're going to wind up with cosecant squared plus cosecant squared minus cosecant. You okay on that?
Yeah, that's
So we have 2 cosecant squared. Okay. Denominator, you have, what's cosecant squared minus 1?
Is cotangent squared.
You got cotangent squared. You okay on that?
Yes, of course.
How'd you go from cosecant squared minus?
Always okay.
Dagger identity.
Okay.
Okay. So now, rewrite it in terms of sines and cosines.
That's
This number 2 is just a constant, so it just stays there. Cosecant squared is 1 over sine squared. Do you agree?
yes.
This is then times 1 over cotangent squared, but 1 over cotangent squared is
Cosine squared over sine squared.
1 over cotangent, so it would be, flip it, you get tangent, so it becomes
Sine,
over,
is it sine squared over cosine?
it is. So now you have 2 times 1 over sine squared times sine squared over cosine squared,
That's fine.
which
Sine
gives
squared
you
cancels out.
2 over cosine.
Which is 2 secant squared. Woo! That's our homework.
Yeah, I don't think 55.
it should work. I gotta look it up.
I'm still trying. Yeah, I got it, and I keep getting the cosecant.
There's another way of starting it, and I'm just forgetting the way I should
Wait,
start.
don't you have like the answer book to this? Or did you
Yeah.
work this out?
This is a very old, from an old textbook.
I was gonna say.
Because even your book doesn't even have a wide selection of these problems anymore, so we have to go searching for them. Do the evens, do the 2 through 36 on the evens on that front page here.
I love having worksheets.
You're gonna need, you'll need paper to do it. They shouldn't be that bad, they really shouldn't. These should go rather quickly. I tried to do today was to show you the painful ones, so that way they wouldn't be as painful as you get in there. I think I've given you enough of ideas as far as how these things should set, so you should at least have an idea of where to start. Hopefully.
Yay.
I hope.
Catch me in the questions.